Here we go. We're now live on YouTube as well. And so, good afternoon, everybody. My name is Alicia Capello, and I'll be the moderator for this Lightning Talk session. As a reminder, each of the presenters have 15 minutes to present, but also to answer any questions. So once we begin, I'm going to paste a couple of items into the chat as reminders, which includes the code of conduct and the email address that you can contact if you've got any technical issues. We ask that you keep yourself muted during the session. And if you can enter in your questions for any of the presenters into the Q&A feature, that would be great. So even if we don't have time to answer them all, the presenters can still respond in that window for you. This session is being recorded and live streamed on YouTube. And if you need to, you can turn on the captions by clicking the Show Captions button at the bottom of the screen. So to start off, it is my pleasure to introduce our first presenter, Michael Sturm II, who is an AI researcher for Rutgers University. Michael's lightning talk is titled From Intake to Instruction, a Human-Centered AI Workflow for Academic Librarians. Take it away, Michael.
Okay, thank you, Alicia. Just want to share my screen here. Okay, so this is my presentation. Thank you for attending. I'm going to go through the presentation. It's fairly short. I know this is a lightning round, but I wanted to let all of you guys know I put a lot of time into creating a web page for this presentation, which is going to have the resources. It's going to have video demos of the workflows that I'm talking about, and also links to access the workflows, the templates, so that then you can tailor them to your own needs. So I'll share that link at the end of my presentation, but I just wanted to jump right in here. Take to instruction, human-centered. The important part is human-centered AI workflow for academic librarians. My name is Mike Sturm. Just a little of my background. I want to make sure that I'm still. Can you guys still see my screen?
Yep.
Okay. Just a little bit of my background, interdisciplinary educator, library professional with over a decade experience in higher education, digital scholarship. My work bridges instructional design, emerging technology, and the mission of academic libraries. So the challenge is librarians spending too much time on administrative triage and not enough on effective instruction. So AI workflow can be helpful in that regard. So very important is the human-centered philosophy. AI is a tool, but the human in the loop philosophy is built on a single conviction, which is that AI should reduce friction, not replace judgment. Automate the intake and organization so librarians can focus on what only they can do. So with these workflows, the AI handles the intake. Specifically, we're talking about information literacy, session requests, the organization, the scheduling, and even first drafts of presentations. But the librarians are the one who lead the pedagogical design, professional judgment, faculty partnership. And together, the classroom-ready materials build on expertise and not guesswork. So this involves a four-step workflow, and there are four interconnected projects. And you guys will really see this clearly when you view the web page that I'm going to share at the end. And it takes a faculty request all the way to a classroom-ready information literacy session with the librarian guiding every step. So it begins with the intake and triage, moves to ACRL aligned planning, over to notebook LM analysis, and finally a gamma export of presentation. And each step builds on the last. So the first step, the faculty submits a structured request form. This is through a Google form, and that moves to AI, which checks the librarian's calendar and drafts a response to the faculty request. Then the librarian reviews and approves what the AI provides. So that email gets sent to a librarian with the draft response, and the librarian has to review that before sending that off. So that's the first step. Forward. Second step is ACRL aligned instruction planning. So this is a workflow that is connected to an academic scholarship API that monitors research in a given subject area. So with this workflow, every Monday, the librarians get an email with surfaced current scholarship in their subject area. They're going to get framework alignment with ACRL threshold concepts. They're going to get discussion prompts, teaching focus points, and a sample of APA style citations for current articles. Now for step 3, in Notebook LM, librarian uploads course materials that they receive from the faculty member. This can include syllabi, the assignment description, the assignment rubric. Then the AI can generate a first draft presentation. And the key part is first draft. The librarian is going to go through that. They're going to make sure that everything's accurate. And they're going to make sure that it aligns with their instructional approach. And then stage 4, you import the outline that came from Notebook LM into a program called Gamma, which is a presentation generator. You customize the visuals and flow, and you can actually upload a sample slide into Gamma with your institution's template or colors. So you can get a customized presentation in that way. And then you're going to export the Gamma presentation to a PDF, and then convert that PDF to a stable PowerPoint via I Love PDF. You can convert the Gamma presentation to a PowerPoint from within Gamma, but I've noticed that in the translation, it doesn't really preserve the nice formatting of the Gamma presentation. So I found that when I export it as a PDF, take it through I Love PDF to convert to PowerPoint, that the result tends to look much better. So ethics and oversight follows 5 core principles. These are AI drafts only. So all the outputs should be seen as raw material and never final. Again, these are like coming up with outlines and first drafts that the librarian is then expected to work with. No student data is ever uploaded. Transparency, be open with the faculty about AI use in preparing the information literacy session. And the librarian is designer. The librarian is the ultimate authority. This is just a tool to make some of that prep work a little faster. So so that the librarians can focus on what they do best, which is delivering and teaching information literacy and human judgment first. Again, like I said, the purpose of AI in this case is to reduce workload, not pedagogy. The workflow is a starting point, not a finish line. Now this, guys, is the web page that I made for this conference presentation. It's going to have walkthroughs of all of these workflows. And it's also going to have the workflows themselves so that you can download them, access them, and tailor them to your own use cases. So I'm actually going to share this in the chat as well. I'm not sure if I can do that this way, but I will share it in the chat. And that is the end of my presentation.
Fabulous. Thank you very much. Michael, we have a couple of minutes. If there was anybody who had a question, there isn't one in the Q&A right now. But if you wanted to raise your hand or type one in there, oh, here we go. Have you tried this process in your own teaching, and what have your best and worst experiences been?
I just want to share this link real quick. I'm sorry, would you mind repeating that question one more time?
Yeah, no problem. It said, have you tried this process in your own teaching, and what have your worst and best experiences been?
So I have not tried this approach in my own teaching. I am currently a library school grad in the capacity of AI researcher. I spent some time giving information literacy sessions at a college library. So I'm sort of remembering back to that experience and trying to see what would be useful.
Makes sense. Another question, have you gotten any pushback, or would you anticipate any for uploading a professor's syllabus and other materials into Notebook LM?
Well, I could see potential pushback, but I feel like a conversation with the faculty member would be pertinent if we're doing that, to see if that's something they would be comfortable with.
Right. Well, thanks to our presentation, which is going to be by Sudha Anand, who is the Digital Collections Librarian from Indiana University. Her lightning talk is titled Encouraging Adoption AI Literacy Through MLIS Coursework. So take it away, Sudha.
Thank you, Alicia. Is everybody able to see my screen?
Yep.
Awesome. Hey, just trying to move Zoom out of my way. So, hello and welcome to my lightning talk titled Encouraging Adoption, AI Literacy Through MLIS Coursework. My name is Sudha Anand, and I'm the Digital Collections Librarian at Indiana University. I also serve as adjunct faculty in the Department of Library and Information Science at Indiana University, Indianapolis, teaching students about various technologies and tools they might encounter in the library profession. Before I begin, I wish to acknowledge and honor the Miami, Delaware, Potawatomi, and Shawnee people on whose ancestral homelands and resources Indiana University Bloomington is built. As information professionals, change is something we have learned to address and handle in the digital age. Beginning with using card catalogs to now helping patrons to use discovery systems to locate items beyond library collections, we have come a long way in our professional mission to advance knowledge sharing and teaching digital literacy. Now, teaching AI literacy is simply the next step in the exponentially advancing digital landscape of libraries. As Pew Research 2026 numbers indicate, 36% of Americans interact with AI at least several times a day, and about half of US adults use AI chatbots. In addition, the numbers also indicate that AI is most commonly used for searching and work related uses, with people even using AI for emotional support. So currently, as librarians, we are well beyond the crossroads, and learning to interact with AI has become an essential skill to master, irrespective of our personal opinions on AI. AI in libraries is here to stay. Irrespective of the type of library space, be it academic or public libraries, AI has become a strong addition to the technology toolkit that we librarians use every day. From everyday work productivity to specialized activities such as research assistance, AI has slowly creeped into the library space. From cataloging and metadata generation to reference services, teaching, and data curation, AI is actively shaping the ways in which information is created, mediated, and accessed. So, as part of MLIS training, it is necessary to prepare future librarians for an information landscape in which AI is not emerging, but already deeply embedded across library workflows. Our patrons are already using AI tools and will increasingly turn to librarians for guidance. Faculty are being introduced to AI for teaching and research and rely on the library and librarian support to experiment and master these tools. Students, of course, are always pioneers in trying out new technology innovations and are exploring different AI options available to them to make their learning journeys more effective. They, of course, need librarians to provide guidance on ethical use and to understand do's and don'ts. Researchers are turning to AI to help them locate relevant sources quickly and help summarize and assimilate content in their intensive research journeys. And within our own institutions, colleagues are adopting AI to support research, teaching, and increase productivity. Vendors are integrating AI into discovery systems and databases, often in ways that require librarian input and oversight. Our institutions are overwhelmingly turning towards AI adoption, and it is our role as information professionals to draft policies and workflows guided by our librarianship values and ethics. We are all using AI without even realizing it, from spelling and grammar suggestions to shopping online. Irrespective of a librarian's opinions about AI, they must acknowledge that just by ignoring AI, one cannot make it disappear or stop others from using it. On the other hand, being informed about it and learning about its biases and shortcomings helps them become better information stewards. Librarians must also remember that one cannot draft a policy on AI to guide their institution without learning about it first. Neither can they recommend or dissuade a faculty, patron, or student from using a specific AI tool without learning about it themselves first. On this slide is a list of common themes I've come across from my time teaching AI to MLIS students. There has been a lot of resistance to look beyond their preformed opinions. But as I said earlier, as librarians, we are information stewards and cannot shy away from learning about AI. So the question is not whether we teach AI literacy, but how. Librarians must position themselves not as passive adopters, but as critical, informed leaders in shaping how these AI technologies are implemented and understood. AI literacy is not simply about learning how to use tools, but about cultivating a broader set of competencies. These include developing a conceptual understanding of AI systems, recognizing where and how AI is embedded in information environments, critically evaluating outputs, and engaging with ethical concerns such as bias, privacy, and accountability. Importantly, the need for these competencies is grounded in practice. As with many other academic institutions, Indiana University offers its community access to pre-vetted and approved AI tools that have undergone institutional review and are approved for use with IU institutional data. These approved tools have regulations in place to utilize data fed into them for training AI tools, so offer a safe space for experimentation and use. These tools made the whole AI learning process easier instead of having to test AI tools for viability and safety while teaching. Here are the instruction goals we focused on in my course titled Tools and Technologies for Information Professions to ensure we provide librarianship students a strong foundation in AI to be able to feel confident in their future librarian roles when confronted with AI-related tasks. The pedagogical approach outlined here centers on combining hands-on engagement with critical evaluation. Students are encouraged to use AI tools in low-stakes exploratory ways while simultaneously interrogating the outputs they produce. This includes identifying inaccuracies, tracing bias, and questioning underlying assumptions. This also helps them identify the best venues to use AI and situations where they should stay away from AI adoption. This course is a completely online asynchronous course, but I offer several options to meet via Zoom or Teams to answer questions and address concerns students might have working with AI. In the first AI module, the students performed textual analysis of a short story to identify suitable subject headings through their personal reading, using AI, as well as through human crowdsourcing through friends, family, or the internet through sites such as Goodreads. They compare the three methods used and identify the benefits and shortcomings of each method. By performing this comparison, they can identify and assess AI as a tool similar to searching the web or talking to colleagues, family, or friends. By having three results to compare, they are able to identify AI's benefits and limitations. In the second module, they are introduced to prompt engineering and the need to revise and iterate their prompts till they receive the results they are satisfied with. This task is performed for a library-related information need, such as programming, generating a reference list, or creating social media content or handouts. They discuss their prompt revisions and how AI responded and reflect on the conversation, building up to confidence in using AI to perform a task for them. They are also reminded that AI is a collaborative tool to be used and not taken at its word. They are also reminded to look for proper citations and how to identify hallucinations by reminding them of source credibility they learned through information literacy principles. Finally, in the third module, they are tasked with journaling their interactions with AI and other technology over a 2-day period and identify bias, recognize how social hierarchies are enforced through systems. They also explain if any of their interactions promoted certain behavior or offered social rewards. Finally, they end with a reflection on when introducing an AI system is the right answer and when it is not. Here are some student responses to task 1. As you can see, there was not a lot of positive response to this one. Most think it is a waste of time and the human in the mix is the better option. But some students did find the silver lining. In task 2, the responses received during the reflection process showed a huge shift towards positive, with several of them considering possible personal and work use cases. I also share one quirky response in this slide, relating AI to a child's coworker or a really fast coworker. Finally, for task 3, tied to the tech journal, the responses received showed some thought with respect to ethical use and how AI propagates algorithmic bias. I want to close this session with examples of 2 job postings, one from an academic library and one from a public library, with the inclusion of AI skills mentioned in the job duties to drive the point home that AI is a useful skill to master for librarians. Though this is not yet common practice, the expectations are there, just not expressed through job postings. Thank you once again for joining my presentation, and I'm happy to answer any questions you might have.
Great. Thank you so much, Sudha. So we do have one question in the Q&A. What do you think of the following statement? Do you think it's true, false, or a combination? A
Mhm.
librarian can be fully AI literate without engaging in using the technology.
I think that is a yes, because as a librarian, it's our responsibility to be aware of these tools and to at least understand the benefits and the limitations of the tool, even though you don't use it personally. If somebody approaches you at, say, a reference desk and says they are trying out this tool and need help with it, we cannot say, no, I will not support AI at that point. As a librarian and maybe a reference desk person, it's our job to help them, right? So I feel like when Google came out, when we had fake news, we jumped to help people. So this is just the next thing in the line. So shying away from it is not going to help anybody.
Very true. Thank you. Our next question is coming from an audience member. So I'm just going to unmute them so they can ask their question. Go
Okay.
ahead, John. Oh, I think you still have to unmute on your end, but I've clicked it. There you go.
Hi, John.
Oh, he's having
Oh.
mic issues. Of course. These always happen exactly at the moment you need them to work properly. Did anybody else have a question in the meantime, if until John's able to get his microphone working? No? Okay, well, thank you so much, Sudha. We're going to now move on to our third presentation of the session. Next, in certainly not least, we have Carl Haynes Magyahar, a research data librarian from the University of Pittsburgh. Carl's lightning talk is titled Beyond Generative AI, World Models and What They Mean for Libraries.
Well, thank you, Alicia. So in this lightning talk, I'll cover what world models are, explain what makes them different from generative AI systems that librarians have focused on thus far, and outline 3 implications for academic libraries. So although their definition remains a subject of ongoing debate, role models are generally regarded as tools that serve 2 functions. The first is representing the world as it currently is by building a compressed internal representation of an environment. And the second is anticipating how it will change over time by predicting what happens next. And crucially, this is given any action that you might take. The term world models was popularized in 2018 when researchers showed that a neural network, that is to say, software that learns patterns from examples rather than from rules a programmer writes down, could watch raw video of an environment and without being given any rules, build its own compressed internal sketch of how that world looks and behave. This mirrors an older idea from cognitive psychology, the theory of mental models, which says that people make sense of the world not by holding every detail, but by compressing it into a simplified internal picture of the parts that matter and how they connect. For example, we use our own mental world models to navigate our surroundings and guide our actions. Our brains simulate our environments with enough fidelity to let us effectively predict what will happen if we pull a book from a tightly packed shelf or tell a colleague our honest opinion, and those predictions help us decide what to do. So what makes world models different from generative AI is that the latter turns prompts into text, images, and video to model what the world looks like, while a world model predicts what will happen if you act. And that difference is why generative systems still fail at physical common sense. For example, a text or video model can describe a car reaching a cliff edge and still get what happens next wrong because it never modeled the physics. So where are world models actually being used? A recent literature review that maps this field sorts the applications into 3 domains thus far. And the first one is autonomous driving. A self-driving car's world model predicts how the scene around it will evolve, what happens if it changes lanes, or if the car ahead brakes, and uses that to plan. The second is robotics. Rather than learn by slow, costly trial and error in the real world, a robot can rehearse thousands of hours of actions inside a learned simulation and then transfer what it learned to the physical world. In one case, learning to walk in the real world in a matter of hours. And the third is social simulacra. And this one is different. The world being modeled isn't physical, it's social. So essentially, researchers fill a simulated environment with artificial intelligence agents and watch how they behave, how information spreads, and how a small simulated town of agents makes decisions. So what does this mean for us? I want to offer 3 implications for academic libraries. The first concerns libraries' acquisition and use of humanoid robots that understand space. And we've actually been piloting robots in libraries for years, and there's scholarship to match. The first systematic literature review of robots adoption in academic libraries appeared recently, synthesizing 16 studies, and it cataloged both the promise and the risk. But notice what those robots had in common. They were narrow. They ran scripted tasks such as reading shelves, telepresence, guiding patrons to a location, and giving tours because they couldn't understand space or predict the consequence of an action. But this is exactly what a world model supplies. As we just saw, a robot with a world model can rehearse in simulation and learn to act in the physical world in a matter of hours. So the risk that earlier scholarship listed as cautionary, such as loss of critical thinking, fear of job loss, the erosion of patron privacy from robots full of sensors and cameras that researchers warned about in 2020, even the outdated syllabus of library science that researchers flagged in 2022, these things stop being speculative and they become operational. The insight here is that the first systematic literature review already provides the foundation for a readiness checklist. Role models are what make it urgent now. The second implication is about whose world models these encode. The core idea is that a world model learns from the world of data, so it can only know the slice of the world its data captured. And what's striking is that the most comprehensive literature review in this field, written by researchers building these systems, is candid about the limitations. On the physical world, the survey grants that knowledge these models absorb is uneven. It reports that their grasp of specific places, cities, urban environments, is often coarse and inaccurate. And it describes a deeper pattern. These systems tend to generalize case by case. They're near perfect on data that resembles what they're trained on, and they break down on cases outside that distribution, what the survey calls case-based rather than genuine rule-based understanding. In other words, whatever slice of the world is in the data is the world they know. Step outside it and the model falters. And the literature review is direct that this training data is vast and often opaque. And it's not only the physical world. On the social side, the survey concedes that getting these systems to model human behavior realistically remains an open problem, and that we largely judge whether the behavior is realistic by subjective human assessment. So whose behavior counts as realistic and who's doing the judging? Asking whose knowledge is represented and whose is missing is not new for librarians. It's close to the center of what we do. What's new is where the question points, not at a catalog or a database, but at models of physical space and human behavior that are increasingly used to make decisions. So the insight is that the field's own survey concedes that the world these models encode is partial and uneven, Libraries are built to ask whose world that is. And the third implication is about the data these models are built on and who curates it. Think about what a world model consumes, not just text scraped from the web, but massive multimodal data, thousands of hours of video, LiDAR, that light detection and ranging, audio, text, and three-dimensional scenes of physical environments, and increasingly something new. These systems train partly on synthetic data generated by the models themselves. Here's the problem that researchers have named directly. This training data is massive and often opaque, and it calls for improving the transparency of how the data is collected, stored, and used. So the provenance of what goes into a world model is frequently unclear, sometimes even to the people building it. And when these systems generate hyper-realistic output, researchers flag a second problem, telling real from synthetic, and holding that content accountable through techniques like watermarking. Now, if we think about the vocabulary, provenance, findability, reuse, accountability for what a data set contains and where it came from, that is the language of research data curation, which is a responsibility that librarians have taken on. We already have frameworks for it, like the FAIR principles, which state that data should be findable, accessible, interoperable, and reusable. But here's the implication. Those frameworks were built for datasets. Applying them to opaque, multimodal, partially synthetic data is genuinely unsolved. Curating a spreadsheet is one thing. Curating the provenance of a 10,000-hour video corpus or synthetic environment a model dreamed up is another thing entirely. So the insight is that stewarding the provenance and reuse of research data is core library work. And world models hand us a new data type or our curation practices weren't built for, which is the next problem for the profession. That ends this lightning talk, and thank you so much for listening. I'll take any questions.
Fabulous. Thank you, Carl. Did anybody have any questions for Carl? You can put it in the chat or in the Q&A because both of them are open on my screen. I can see them. Nothing is popping up, Carl, but thank you so much for your presentation. That was the 5-minute warning. It just went off. So if nobody has any questions, then I think we can wrap up our session a little early. I'd like to thank Michael, Suda, and Carl for their presentations. Everything was great. And please have a great time at the rest of the sessions for the rest of the week.